In this lesson we will perform protection coordination study in Etap. So I have a single line diagram in Etap over here. So we will be performing the protection coordination for the single line diagram using our current release. So to begin with, I will start the writing of these elements over here. And I will write the transformer. So the transformer will be 110 bar 11 kV 12.5 MVA with a typical impedance values over here. And then we will start with the load over here. The load will be 70 amps. So that is it. And the cable, I will select a cable from here, and the cable length will be 10 meters. And go to the library and I will pick one cable. Okay, I will select this cable over here and I will select this size. So then go to the loading page. I will update the operating current as well, and the ampacity will be the derated ampacity. And then for the transmission line over here, this will be 1 mile length, and I will go to the conductor library and I will pick, okay, I will pick this one, which is a 250 size. So I will select this one, and as usual the earth wire will be the same, and this will be at a height of 30 feet, which is placed at 2 feet. So this updates the GMD, and I will go to the ampacity and use the derated ampacity, and then we will perform a simple load flow study over here. So load flow study, okay, everything is good. Here we have 6.8 amps, 7 amps, 78.2 and 70.2. And let me go to the edit study case and I will update the cable load ampacities. Okay, then we will go to the short circuit study, and I am going to look at what the short circuit current over here is. So here we have 7.82 kilo amps. So this is the maximum fault current occurring at this bus. And in order to perform the protection coordination, you actually need protective devices such as circuit breakers. So Etap provides you with fuses, contactors, high voltage circuit breakers and low voltage circuit breakers. Here we will be using the high voltage circuit breaker. So I will double click on the circuit breaker and I am going to place it here, here, here and over here. You actually need relays for this operation, and in order to sense the current you will require CTs. So go to the instrument toolbar over here and I will select the current transformer and I will place this here, here and over here. Then for the relay, Etap has numerous relays: voltage relays, reverse power relay, frequency relay. We actually require, for this simulation you will require the overcurrent relay. There is also the solid state relay, which I will show you in the next lesson also. So go to the overcurrent relay and place it adjacent to the current transformer. And now we should write for our circuit breakers over here. Double click on the circuit breaker, and for this simulation or for this demonstration I will be using the ANSI standard. So go to the library. Okay, I will use the ABB manufacturer and 121 maximum kV. I will choose this one, and the same will be used over here as well. And for this circuit breaker I will select a different breaker, which is over here. Okay, this 15 kV max with the ABB manufacturer itself, and the same will be over here as well. and then we need to rate our CTs. So I will start with the CT over here. So the CT rating will be, I'm going to provide in 100:1 the CT ratio, and the burden will be say 50. Here too will be the same rating, 100:1, 50 VA. Over here we have 10:1 CTs, again burden will be 50. Here too I will use the same one. So one thing I want to specify is that all the ratings that I am using in this simulation or for this demonstration are not actually available by the manufacturer. I am not sure you will be able to use 10:1 CTs or 200:1 CTs. So you actually have CTs that are provided by the manufacturer for fixed CT ratios, such as 200:5 or 1000:1 or so on. So you will have to look at those in case of actual projects or practical projects. I plan on for doing a design project in Etap. We will do that sometime later in this course. So next I will have to go to the relays. I will select the input tab over here. So the input tab, I have the CT already connected over here, so I don't require anything else for the input tab. And for the output tab I will have to add a circuit breaker. So when this relay operates, I want this circuit breaker to be open. So I can select any of the elements of the relay. I can in particular select the phase element, the neutral element, the ground element, or anything else, but let me keep it simple. So any element of the relay provides trip signal to the circuit breaker, so this circuit breaker will be open. And similarly for these as well. So we have all our outputs configured, and then what we have to do is look at the overcurrent relay settings. So let me pick a relay from the library. So I will pick the Alstom P139, which is a Mycom brand name. So Mycom brand name, and this overcurrent overload protection for cables, lines, transformers and motors. You can select the relay depending upon the function like this, or you can just take it depending upon the protection type for the generator, transformer, bus or so on. So I will use the P139, and for now I will put everything in the default, and let us see. I'm going to select everything to be the P139. So I have selected all the P319s. So everything is set for this protection coordination, and then we will go to the protection coordination mode or the star mode. Etap calls the protection coordination as the star mode. So here we are in the star protection device coordination, and here we have some of the options over here. This creates a star view. This is the star view manager. This runs or update the short circuit kiloamps, and the fault insertion, PD coordination, which is the protective device sequence of operation. So let us begin with the downstream or the load side. So actually when performing the protection coordination, you actually need to start from the downstream and gradually move up to the upstream. So first we have to operate this breaker, then this breaker, and so on. And I will select the entire single line diagram, and on the right side I have this option over here, protection zone viewer, and when I click on this option, this categorizes my protection elements into various zones. So for this single line diagram I have 3 zones, one involving the source and one involving the transformer and the other involving the zone. So I can create different star views. Star views are simply the time current curves. So I can create individual star view per zone, or create a single star view, or actually add it to another star view, and so on. So let me begin with creating individual star view per zone, and when I click on create, Etap provides me with the star view or the time current curves and this is for the source. Over here we have 2 relays for the source and 2 breakers for the source, and this is for the relay 1 and this is for the relay 2. So these are the curves which I mentioned in the previous lecture. These are the time current curves of these relays, and in Etap you can perform protected device coordination by simply moving these up and down. So that's as easy as it can be. So, and when I double click on this relay, I actually get the overcurrent relay editor. So you can see this curve, this is over here the ANSI extremely inverse curve, and you can see here this is the instantaneous part of this curve. So for this demonstration I will turn off the instantaneous mode, so this will be more easier to explain and graphically more easy to understand. And for the ground also I am going to disable that. And let me close this. Here we have the relay 2 and the relay 3. So these are in protection zone for the transformer, and here you can see the damage curve of the transformer. So one thing you have to make sure is your relay characteristic always stay to the left side of this damage curve. So the relay operates before the damage curve is reached. So I will close this, and this is for the lump load over here. So here we have the cable ampacity limits, you can see that over here. Then I will close this as well. So for simplicity in understanding, I am going to turn this off, and every curve will be ANSI normally inverse. Except for the ground mode, which I will do that later. So now we have everything we need for our protection coordination study. So to begin with, I will put in a fault insertion. I will insert a fault at this bus over here, and I can observe the sequence of operation of the breakers. So you can see I have not coordinated any of my relays. So the sequence of operation is coming from the upstream. So this is a very bad coordination, because you actually need this circuit breaker to open first, then the circuit breaker, and you have to go from the downstream to the upstream breaker and not the other side. So let me simply go to the edit steady case option over here and go to the sequence of operation. So the fault type is 3-phase fault, and I'm going to flash 4 devices, and here we know that the ampacity or the amperes for required by the load is 70 amps. So while setting the overcurrent relay, I will select some additional percentage. So say here I am going to put in like 0.8, and if you look over here we have the pickup range. So in this relay we have two coils, so this is 4 times CT secondary, so I will use this curve. Here we have limited to 0.8, so from 0.01 to 0.8 amps. So my relay is 100:1, so I actually need 1 amps for the protection, so I will use the second coil over here, and I'm going to provide a pickup for 80 amps. So Etap shows you the primary amps over here, and the time coordination I will perform this in the graph. So I will first arrange the pickup values, and this will be 0.9. okay, we'll put, okay, I'll change the, okay, 0.9. and over here we have the current. Let me see, the current is like 7 amps, so we have to look at that. And the current, okay, 1.26. okay, I have put in a value like 1.26, so maybe I should put in 1. okay, 10 amps will be the overcurrent protection, and over here we will put in 1.2 or so. So I'm going to check that everything is in the normal inverse. I have to make sure everything is in the normal inverse. Okay, and now let me select my entire single line diagram, and I'm going to create a star view from this. So you can see the entire TCC curve for the entire single line diagram. I have the relays and everything over here. I want to show you the features of the star mode. So we have the zoom options, span options, and you can actually put in the single line diagram outside over here, and when clicking on this option you can enlarge this. And so this is the damage curve of the transformer, this is the ampacity limit of the cable, this is the ampacity limit of the line, and this is the transformer 1 inrush current, the limit of the lump load. These are the relay curves, and on the right side we have the mode. We can put it in the ground mode or the phase mode. So now we are in the phase mode. We can zoom, and we can also use the crosshair in order to find the amps and the seconds of operation, and there are several other options as well. You can also plot a curve. It provides you the option to provide a new curve, so I don't want to provide a new curve, so let's close that, and let me close this. Okay, we have the also option for providing the grid. So this is the grid, and there is also several plot options: axis, general, legend, devices, and so on. So let me close this, and I am going to put in a fault at this bus, and as before everything is in the same. So I am going to select my entire single line diagram and go to the star view. So now we have, let me keep my single line diagram out of the curve. So we have all the relay curves in the single line diagram, and this point is the point of fault. So let us actually coordinate between the operations of this relay. So my curve 4 or my relay 4 should be the first to trip. So I will bring up the relay 4, then I will bring up the relay 3. So how you perform protective device coordination from the TCC graph is to make sure your upstream breaker is always towards your right side. So the upstream breaker should be above every downstream breaker. So here the upstream breaker is relay 1 and this is relay 2. Okay, so now we have the relay 1, relay 2, relay 3, everything is in perfect order. Over here you can see when a fault occurs, the relay 4 will be the first to act, then relay 3 will act, relay 2 will act, and so on. You can actually turn in the settings from over here, and you can observe the time difference between the two operations over here. So let me see, from this curve to this curve, the coordination time interval is 0.195 seconds. So let us see if we actually perform the coordination. I will go back and then we will go to the fault insertion and provide a fault at this bus, and now you can see we have actually performed the protective device coordination. So you can see the first device to be operated is the CB4, then CB3, CB2, and then CB1. So let me go back again. I don't want to put in a large value of TMS, so I will bring these curves below over here. Okay, then let us check this out again. Okay, everything is good for this case when the bus 4 is faulted, and then we will perform the fault sequence insertion on this bus over here. This is the bus number 3, and when running the sequence, okay, here we have a miscoordination over here, so we will go to the TCC curve and observe. Okay, now let us observe again. So now I have adjusted all the TMS values for all the relays from the graph. As you can see, when I plot the graph, if I had to remove this, okay, when I plot the graph, we have these relays over here, and the protection coordination is working well for the phase element. And similarly, we will have to do this for the ground element as well. So normally inverse pickup will be for 1 amp. Here this will be for 1 amp as well. Here this will be for 5 amps. Okay, let me put this for 10 amps. This will be for 12 amps, I suppose. We will put this for 12 amps. Okay, and go to the edit steady case option over here, go to the sequence of operation, and we will put it line to ground insertion. And when I run this, okay, here is again a miscoordination over here, so let us correct that. And to correct that, I will go to the star mode again, and from the star view I will change this to the ground mode. So now we are in the ground mode, and you can actually see any of the graphs over here. So I will go to the plot options, and I'm going to resize the current multiplier. So now we have 2 of the graphs over here. So let me bring this over here. So when we have a fault at this bus, you actually need the relay 4 to operate first. So we'll make the relay 4 operate first and the relay 3 operate later. So let me close this. The relay 2 and the relay 3 are not in the picture because the fault is from this end. So I will close this, and when I run the fault insertion again, you actually see these 2 circuit breakers are opening. And similarly in this case again we have a miscoordination, so we'll have to coordinate that also. So let me go over here, go to the plot options, to the axis, and rescale that. 2 graphs over here. I am going to select the 2 graphs, and I'm going to first drag this out of the way, and I'm going to pull this. The relay 2 has to be operated first, so the relay 2 will come down. So the upstream devices goes on the top and the downstream devices go on the below. So that is the basic idea when you are providing protection coordination by means of the TCC graph. And when I run the fault insertion again, you can see it's now perfect. So just to make sure everything goes well, we will do some more fault insertions. Okay, our fault insertion coordination was pretty good. Okay, you can also observe the sequence view over here. This shows the time and the operation of all these over here. You can also generate reports from over here, and this is how you perform protective device coordination in Etap. So the protection device coordination is actually pretty difficult. This is a simple system, but with experience you can be quite good with it. So in the next lesson we will discuss more about the production device coordination, and see you in the next lesson.